Okay, let's talk about how we can find the area of the circumcircle of a triangle. And a circumcircle, it's a circle that goes through all three vertices of a triangle. And the triangle that here we have is with sides 2, 3, and 4. So the goal is to find the area of the blue circle. Well, to find the area of a circle, we have to have the radius, right? And to have the radius, we need to have its center. So let's say we have the circle, the center is somewhere here. And let's draw the radius. We can go from the center to here. So this is how we can relate the circle and the triangle. And that will be the radius. Okay? But I don't think this is enough, so why don't I draw another one? If I go from here to here, that will also be the radius. Now, it looks pretty good. But how can we continue though? Well, we have R, and 2. So if we can somehow break it down more, then yeah, but let's have some angles to help us out. In fact, there's a nice connection between this angle here and if you just go away like this, because both angles subtend the same arc right here. So you will have to know some geometry fact in order to kind of continue. And I'll tell you, this angle, when you have the center here, it will be twice as big as this angle where it's on the circle. So if we have this angle here being theta, then we can label this angle here being 2 theta. Okay, it looks pretty good so far, but now what though? Well, can we find out what theta is? In fact, yes, because we have all three sides. So we can use law of cosine. Okay. In that case, I think we can find out theta and then somehow produce, but I still have to connect r and theta from this picture, right? So this is how we do geometry. You will have to kind of just break it down more and check this out. Look at this triangle here. Let's go ahead and draw a perpendicular from here to here. Okay. Then what can we say? Have a look. This is the radius, that's also the radius, so they are congruent. And this is congruent to itself. More importantly now, this and that, they are both right triangles, so you can use the Pythagorean theorem. You can argue that this side will be congruent to that side. So in fact, these three sides are the same as these three sides. So these two triangles are both congruent. So that means this is actually not just the perpendicular, but it's actually the perpendicular bisector. So you can further argue that this right here is just half of the whole thing, which is the angle theta. And then if you go here, this side is just half of the whole thing, which is 1. So we can look at this triangle now, and it's a right triangle, so you can just do the simple sine cosine business. And here, we have the opposite and hypotenuse, so we can use sine. Have a look. We know sine theta will be opposite over hypotenuse, which is 1 over r. And I want to figure out what r is, so we can say r is equal to multiplied here, divided here, so it's 1 over sine theta. Now, per our discussion earlier, we can actually use law of cosine to figure out this angle here, which says cosine theta is equal to this squared plus that squared, right? It's the sum of the squares of the adjacent sides. So 3 squared plus 4 squared, then we have to subtract the opposite side squared, which we have 2 squared, and then divided by 2 times its adjacent sides, so 3 and 4. And now let's just work this out. This is 9 plus 16 minus 4, that will give us 21. On the bottom, multiply this out, we get 24. 21 over 24, we can reduce that and we get 7 over 8. Here, have a look. R is equal to 1 over sine theta, and here we have cosine. Based on this, we can figure out what sine theta is, which we use this identity. Sine theta equals, I just want the positive square root technically it's plus or minus, but the angle here is acute because we have 2, 3, and 4. This is the smaller side of the other two. For sure, it's acute. And the formula is 1 minus cosine and then square and then theta. So we can just go ahead and figure this out. This is square root 1 minus cosine theta is 7/8. And then square that, work that out. This is square root of, that's 49/64. And then that's 1 minus 49/64. And then just get a common denominator and all that stuff, 64 and then 64. So 49 minus 64 is 15. On the bottom we have 64. And I'm just going to leave it as square root of 15. And square root of 64 is nice number 8. So r is equal to, let me write this down again. And we just have to do the reciprocal of this, which we get 8 over square root of 15. And to answer the original question, to find the area of the circle, well, we just need pi times r squared, which is 8 over square root of 15. And then square that, work that out, we'll get 64 over 15, and then let's put a pi next to it. And that will be the answer of this right here.